Hello and welcome back to another set of video notes from me, Mr. Basil, your favorite ever chemistry teacher. And yeah, we'll get started here in just a moment, but before we get into the good stuff, just to review, this is Learning Target 4.1, which is all about types and classifications of particles. In the previous video, which you should have watched already, we talked about the definitions of all the different terms that you need to know for this unit. And if I didn't talk about this before, but approaching level is basically enough to understand the ideas of things, but not enough to pass chemistry. Basic level is enough to pass, but maybe not enough to get an A. But it's definitely, if you're just looking at passing chemistry, you need to know approaching and basic level. If you're looking at getting an A, generally speaking, you're going to want to know everything. So approaching, basic, and the meets level. At the point that I'm at right now, this might not be true in the future, but currently, as I'm making these videos, you're never going to see extends level on anything. So that's why you'd be able to get an A, just based off of those things. This learning target in particular, you'll notice I just have approaching and basic. So if you know approaching and basic for this one, that's enough to get an A, if you just were doing something for 4.1. But anyway, I'm getting a little bit beyond that. So let's just get back to the idea of what this video is about. So basic level, we're just gonna, my expectation is that you know how to recognize particle diagrams for all these different terms that I have written here already. So let's go ahead and without further ado, dive in. Alrighty, so I think one of the easiest things to start off with is an atom. So an atom can be represented as just one thing by itself. And there's a couple different ways that we can, oops, that's fun. Let's get rid of that. There we go. So you can have just like a generic type of thing where it's more related to like the POGIL that you did, and just have shapes. So things like this. These, like, so this right here would be an atom, this over here would be an atom. But that's not necessarily, and you know, sometimes I'll have you draw things like this, but then you also have the more applicable things, which are actual elements. So, you know, it could have like Fe, or Ca, or Na, or Cl. Those are all just different atoms, and you know, I could represent them just with the chemical symbols, or I could put them in like, you know, a shape like this too. So these would all be examples of atoms. And then you could have things where there's groups of atoms. So something like this, where when they're touching, that's showing a chemical bond. And so this would show 2 atoms. And the same thing if I did something like this, 2 bromines together, either just drawn with just their symbols, or what might make a little bit more sense is if I draw them like this. And I redrew that because they weren't exactly touching, though you could probably get that as well. So this is also 2 atoms together. All right, moving on forward to a molecule. So remember, a molecule is just 2 or more atoms chemically bonded. They could be the same or different atoms. So here are some examples. So this is an example of a molecule. They're both the same, and that's fine. You could have something like this, NaCl. So those 2 are bonded together, and it is a molecule. It so happens that this is also a compound, but we'll get to that when we get to the next one. And then you could have something more complicated, like H2SO4. That is sulfuric acid, and the particle diagram for that would, you know, we're going to want 2 hydrogens, 4 oxygens, and then just 1 sulfur. So let me see if I can whip that together here. So we got sulfur, and then 4 oxygens, 1, 2, 3, 4, and then 2 hydrogens. I don't know, doesn't really matter where I'm drawing them, you know, something like that. That would be another molecule. It'd be a complicated molecule, but it's still a molecule. Keep in mind, since there are also different ones, just like NaCl, these also classify as molecules, though this one is only a molecule and not a compound. This is a molecule and a compound. This is a molecule and a compound as well. So here's just some more examples of things that would only be molecules. So only molecule, only a molecule. then let's see, I'll go over there and say that those are molecules only, and then these are molecules and compounds. Okay, so again, a molecule could be just a molecule, or it could be many things, just like some of these other things. Speaking of which, particles, that's what's next. So remember, a particle is just a small portion of matter or a single atom or groups of atoms together. This is the most general thing that we're going to come across. So this is a particle. This is a particle. Everything that I've drawn in your notes now and for the rest of this are also particles. So all of these examples are also particles. So when I said molecule only, really it's molecule only, molecule, but also particles. I don't usually use that in my classifications because, again, everything is a particle in a particle diagram. That's why it's called a particle diagram. Oh, I get it now. All right, next one is an element. That's this row right here, which, remember, it's a pure substance that's only made of the same atoms. And so that could put you into a category like this. My two triangles are a good example I just keep using over and over again. This is an element. This is also an element. And just a circle by itself is an element. So those are your general ones. But then you also have like the actual chemicals. So that's O2. That's an element. Fe would just be, oh, well, Fe. Nothing fancy about that. And then we've had this one before in a different example as well. Br2. That's also an element. So you can have these singular ones by themselves, or you can have these pairs, or it could even be more than one pair. Like you could have, 3 sulfurs together. Maybe that's 3. All of those count. Now, we'll loop back to this more in the future, but it doesn't hurt to start thinking ahead now. But let's see what colors to use. I'll use this color. When you have a group of 2 like this, these are known as diatomic elements. So also a diatomic, and then these ones would also classify for that as well. These are known as diatomics because di means 2, and then atomic is just atom. So they're 2 atom elements. And so there's a list of these that you'll need to know eventually. There's 7 of them altogether, but all that you need to know is that when it's a group of 2 like that, they're just known as diatomic elements. All right, moving on to compounds. All right, so this is, again, similar to molecules, and we kind of touched on this already, but for the particle diagrams, it's a group of 2 or more different atoms chemically bonded. It cannot be the same. So let's just use some examples from earlier. So let's see if I can do a different color. Let's go with, no, let's just stick with what we've been doing, so purple. So NaCl. So NaCl, that's a compound. It's 2 or more different atoms put together. Then you got your H2SO4. Another one I did before. It's that complicated one, but this is also a compound. So got the 1 sulfur, 4 oxygens. And then it doesn't matter really where we're putting these. There's a rule that you can follow, but it's not important. But I have some that are the same. Some of the oxygens are the same, but there's at least 2 different atoms in this compound, or in this molecule, so then that qualifies for that. And then here's just a more generic one. That would also be a compound. This is not a compound. That is just a molecule. And so one thing that you might notice here is that if you're starting to kind of categorize things in your head and understand these are all molecules. And so maybe something we want to add back into our definition from before is that all compounds are also molecules. Okay. The reverse is not also true though. So not all molecules are compounds, but all compounds are molecules. So try to sort that one out in your head, right? Can be a little confusing, but I think you get the idea. All right, so for this next one, I'm going to do a couple different boxes here just to make sure that we have them separated. So a pure substance is something that cannot be separated by physical means. All of the particles are going to be the same. So you might want to go back and add that into your definition. So here's what I mean by that. So let me zoom in here. So you could have something like this, where they're all just, the individual atoms are the same. But remember, a particle is just a group of particles. So these are just one atom particles. Could also have something like this. We've got Br. Let me make this a little bit thinner. Br, 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 and then I don't know, another Br, Br. Okay, and these are separated. Okay, so all the particles are Br2. These are just, I don't know, T for triangle. Each individual particle is the same. You could also have something like this. NaCl, 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 and so on. We could just have a bunch of them. It's not that they're always three. I don't want that to be what you're thinking. Okay, so notice how, like in this one, all the atoms are the same. In this one, all the atoms are the same. In this one, we have different atoms, but each individual unit, each individual particle is the same. Okay, so in this one, it's all in. Oops. All of these ones are NaCl compounds. Okay, so both of these. So this first one would be a pure substance that is an element, and just atoms. This is atoms. Elements. This one is a pure substance that is molecules. Molecules. And an element as well. This one would be a pure substance that is just a compound. And I suppose also a molecule. Okay, so you can have pure substances that are made up of different kinds of particles, but all of the particles must be uniform or the same throughout. All right, last one, we're almost there. So this is for mixtures. So it's something that can be separated by physical means, but you can also add into this that not all of the particles are the same. Not all of them are the same. Let's zoom in again, and we'll have a few different examples of this. I'm trying big boxes just because I kind of ran out of room in the last one. So here, keeping it more general, this is like what you saw on the Pogel activity. Notice how there are two different kinds of particles here. You've got one that's just the triangle by itself, and this one is the RSQ, the round and square, together. So there's 4 different particles here, and 2 of them are different, right? Let's go over another example that's closer to reality. So NaCl, NaCl, and if I ended here, this would be a pure substance, but let's say I have some bromine atoms that are scattered in here as well. So again, individual particles. These 2 are different. So that's what would qualify this as a mixture. And then I don't have another one written down on my paper here, but I bet I can just make up something. Oh, let's say, let's choose one from before. Let's say O2 and Br2. If I ended here, it would be a pure substance. If I ended here, it would be a pure substance, but now it's a mixture because I've got some O2 and I've got some Br2 that's in this mixture. So there you go. There you have it. Those are all the wonderful things you just had written down. Thanks for listening, and I'll see you next time.